Hi to everyone. In this video, we are going to discuss the introduction to limits of function. The objectives of this lesson is to illustrate the limit of function using table of values, graph the function. Let's discuss the two-sided limits. A function f that is defined at some open interval I has the limit L as x approaches to a. So x approaches to a and written as limit of f of x where x approaches to a is equal to L. If we can get f of x as close to L as we wish by taking x sufficiently close to a but not equal to a, we say that the limit of f of x where x approaches to a is equal to L, and only if the limit of f of x where x approaches to a is equal to the limit of f of x where x approaches to a of the right side is equal to L. Furthermore, a two-sided limit f of x where x approaches to a is equal to L does not exist if the limit of f of x where x approaches to a left side of a is not equal to the limit of f of x where x approaches a positive or on the right side of a, or either of one-sided limit of f of x where x approaches to a negative or limit of f of x where x approaches to a positive is equal to L fail to exist or does not exist D and E. To understand these two-sided limits, let's have an example. Find the limit of x squared plus 2 as x approaches to 3. So limit of x squared plus 2 as x approaches to 3 can be written as this one. Limit of x squared plus 2 where x approaches to 3. Okay. When we say x approaches to 3 on the left side, we're going to use the number before 3. Okay? So what are the number before 3? So possible that that is 2.9. Come closer, 2.99. Closer to 3, 2.999. Or 2.999 and so on. So we're going to use this number to evaluate the function where x approaches to 3. So since it says here that x approaches to 3, we're not going to use 3, but we're going to use numbers closer to 3. So these are the numbers closer to 3. If we're going to use 2.9 in the function, so evaluate, use 2.9 in the function, so this will become 10.41. Okay? If we're going to use 2.99 in the function, so x is equal to 2.99, so this function will become 10.9401. Okay, next, 2.999. Use this 2.99 in the function, so the function will become 10.994001. Next, 2.9999 use in the function, that will become 10.999400001. As you can see, the value of the function is getting closer to 11. So we can says here that the limit of x squared plus 2 where x approaches to 3 on the left side of 3, the function is getting closer to 11. Okay? Next, how about on the right side of 3? Okay? So we use 3 positive. So the limit of the function where x approaches to 3 positive, so we're going to use the number on the right side of 3. So the closer number, the right side of 3 is 3.1. Getting closer to 3, we can use 3.001. More closer, 3.001. And getting closer, 3.001. So it is more approaching to 3. And we're going to use these values to evaluate the function. Okay, if we're going to use 3.1 in the function, that will become 11.61. And we're going to use 3.001 in the function, that will become 11.0601. Okay? And if we're going to use 3.001 in the function, the equivalent now of the function is 11.006001 and 3.0001, so the function will become 11.000601. So as you can see, if we're going to use a number closer to 3, so the function will become getting closer also to 11. Okay, so that is approaching to 11. So as x approaches to 3, the function approaches to 11. So since they are equal, we can says that the limit of the function x squared plus 2 where x approaches to 3, this is equivalent to 11. So the function value appears to getting closer to 11 as x gets closer to 3. So we can say that the limit of x squared plus 2, x approaches to 3, is 11. Example number 2. Find the limit of x squared plus x minus 4 where x is approaching to negative 1. If we're going to find the limit of the function, we're going to use the number getting closer to negative 1. So the limit of the function x approaches to negative 1 negative, it means that we're going to use the number before negative 1, closer to negative 1 on the left side. So what are these? So we're going to use negative 1.1, negative 1.01, negative 1.001, negative 1.0001. So which is these are closer to negative 1. So if we're going to evaluate the function using this, okay, negative 1.1, so the function that is equivalent to negative 3.89. And if we're going to use negative 1.01 in the function, that is equivalent now to 3.9899. If we're going to use negative 1.001 in the function will become equivalent to 3.998999. Negative 1.001 in the function, okay, that will become negative 3.9998999. As you can see on the value of the function as x approaches to -1, this is become closer to -4. As x approaches to 1, the function is getting closer to -4. How about on the right side of -1? So the limit of the function x squared plus x minus 4, where x approaches to -1 positive. So we're going to use the number after -1 but closer to -1. So what are these number? So we're going to use negative 0.99, 0.99, 0.0999, 0.9999. Okay, so evaluate the function using these values. So we're going to substitute in the function. If we're going to use negative 0.9, the function is equivalent to negative 4.09. Okay? If we're going to use negative 0.99, the function will become negative 4.0099. Next, negative 0.999. So that will become negative 4.000999. Okay? And if we're going to use negative 0.9999, so the equivalent of the function will become negative 4.00009999. So as we can see, as x approaches to -1, that is approaching to -4 also. In the theorem, okay, if both is equal, the limit of x squared plus x minus 4, where x approaching to -1 is equal to -4. Example number 3. Discuss the limit of x squared minus 4 over x minus 2, where x approaches to 2. Okay. So x approaches to 2. So we're going to use numbers before 2, so the left side. So that is 0.99, 1.99, 1.999, and 1.9999. So evaluate the function using these values. If we're going to use 1.9 in the function will become 3.9. Next, 1.99, the function will become 3.99. Using 1.999, the function will become 3.999. And if we're going to use 1.9999, that will become 3.9999 of the function. So as x approaches to 2, the function approaches also to positive 4. Next, on the right side of 2, so x approaching to 2, which is we're going to use the number after 2, but closer to 2. Okay, so what are these numbers? 2.1, 2.001, getting closer to 2, 2.001, or 2.0001. So let's use this to evaluate the function. If we're going to evaluate the function using this 2.1, the function will become 4.1. Next, if we're going to use 2.01, the function is 4.01. 2.001, the function will become 4.001. Using 2.001 in the function, evaluate, substitute on x, that will become 4.0001. As we can see, the value, as x approaches to 2, the value of the function approaches to 4. So Since these are equal, the limit of x squared minus 4 over x minus 2 as x approaches to 2 negative is equal to the limit of x squared minus 4 over x minus 2 where x approaches to 2 positive. So the limit of the function x squared minus 4 over x minus 2 as x closer to positive 2 is equal to 4. But if we're going to graph this function, so getting closer to 4 as x closer to 2, okay, as x closer to 2, the function is closer to 4, okay. That's the graph of the given function. Example number 4. Does the limit of f of x exist if f of x is equal to 2 over x plus 2 as x approaches to negative 2? Okay, so if we're going to write the limit, so the limit of 2 over x plus 2 where x approaches to negative 2. So to evaluate the function, we're going to use number closer to negative 2. So the number to the left side of negative 2, you have negative 2.1, 2.01, negative 2.001, negative 2.0001. So if we're going to evaluate the function, substitute x by negative 2.1, the function will become negative 20. Next, if we're going to use negative 2.01, the function will become 200. If we're going to use negative 2.001, the function will become negative 2000. And if we're going to use negative 2.0001, the function will become negative 20,000. So, as we can see, it is going to negative infinity. Okay, let's try on the right side of the function of 2, negative 2. So we're going to use number closer to negative 2 on the right side. So what are the number closer to negative 2 on the right side of that? We have negative 1.9, negative 1.99, negative 1.999, and negative 1.999. Okay, evaluate the function using this. So substitute, so 2 over x plus 2 using negative 1.9 in x. So the function will become positive 20. And if we're going to use negative 1.99, that will become 200. And if we're going to use negative 1.999, that will become 2000. The function is equivalent to 2000. And if we're going to use negative 1.9999, that is equivalent now to 20,000. So using these values of x, the limit of the function approaches to negative 2 on the right side, which is approaches also to positive infinity. Okay, so this is approaching to negative infinity and this is approaching to positive infinity. They are not equal. Okay, so you may observe that no matter how we get closer to negative 2 on either direction, the value of the function significantly increase and decreases without bound. So the value of f of x do not cover into one particular point. So hence, we can say that the limit of 2 over x plus 2, where x approaches to negative 2, does not exist, or D and E. So that is the theorem all about. And if we're going to graph the function, okay, so this is the graph of the function. As x approaches to negative 2, okay, so if this is our negative 2 and we're going to use the number closer to negative 2, so the left side going to negative infinity, and on the right side of negative 2, the function is going to positive infinity. Again, this is an example of limit does not exist. Let's discuss one-sided limits. So one-sided limit, suppose a function is defined for all x near a if f of x can be made arbitrarily close to number L for all x sufficiently close to but not equal to a. From the left, then we write this one. And if in the right hand limit, so x approaches to a positive. Okay, so we have the left hand limit and we have also the right hand limit. So let's have an example. Example number 5. Let's discuss the limit of function f of x equal to the square root of x minus 3 as x approaches to 3. So the limit of square root of x minus 3 where x approaches to 3. So we're going to use number approaching to 3 on the left side and on the right side. So what are the number on the left side of 3 but getting closer to 3? Okay, we have we have 2.9 closer to 3, 2.99, getting closer, 2.999, or 2.9999. That is approaches to 3. But if we're going to use these values of x in the function, example, this is 2.9. 2.9 on x, 2.9 minus 3, that is negative 0.1. So the radicand will become negative. Okay, so if we're going to use these values of x in the function, the radicand will become negative. So cannot be. So this is cannot be. We cannot find the value of the function using these values because the domain of the function is greater than 3. This is a radical function. The domain of the function must be greater than or equal to 3. But if we're going to use the number after positive 3, so on the right side of 3, we have 3.1, 3.0001, 3.001, and 3.0001. Okay, so we're going to evaluate the function using these values. So 3.1, if we're going to use 3.1, the value of the function will become 0.3162. Next, 3.01, so the function will become 0.1. Next, 3.001, that is equivalent to 0.0316. And 3.001, that is 0.01. So the value of the function as x approaches to 3 is getting closer to 0. So this is an example of right-handed limit or one-sided limit. So the limit of square root of x minus 3 where x approaches to 3 is right-handed limit. The limit is defined all x in the interval, okay, in the interval 3 to positive infinity. So the value of x greater than 3 or right side of 3, the function is defined. So on the left side, this is not defined in the interval of from negative infinity to positive 3. So here, we can say that the function does not exist because in the theorems earlier, both side of the limit should be existing. So since this is not existing and here is existing, the limit of square root of x minus 3 where x approaches to 3 does not exist. But we can say that this is an example of a one-sided limit. That's about the introduction of limit of function.